There we go. One is the Google Sheets sheet that you have, okay? The other one is your notes out because that's where we're actually going to take our data and process things and understand. So you should have this sheet. Remember, this is what we were doing yesterday. As you're getting your brains back into this, because it's been a few hours since I saw you last, we took some data and we graphed it and we saw that they were parabolas. And that was interesting. We say, yay, parabolas, not a surprise. We're excited that they're parabolas, but we want to do some linearization, right? Lines mean something to us. Parabolas can, but it's harder to get stuff out of it. It's especially harder to get stuff out of it if you're taking like an AP test, right? And they're asking you to tell me the blah, blah, blah. If you are looking at a curve, you have to like approximate things, but it's pretty darn easy to find the slope of a line. You can do that in your sleep probably even. So I bet you can handle that. So we decided to make a line. I don't know if you remember from yesterday, but we did. We made some lines right over here, didn't we? What did we do? We just said, oh yeah, time squared and distance. Hey, that gave us some lines. And we found the slopes of those lines. And we thought maybe they would mean something, so we decided to write them down. And we made this little chart. I'm just kind of reminding you of where we were, because otherwise I'm just jumping into something that doesn't make sense. We found that the units of the slope were meters per second squared, which is interesting. Okay, and we wrote those slopes down. And that's kind of where we were. Oh, and then we started to do velocities, didn't we? That's what we did, because we realized that acceleration is also just change of velocity over time. And so then we were looking over here, and we said, we did start calculating velocities, didn't we? Yeah, good for us. And did we maybe didn't quite get them done? So if you didn't get them quite done, you're going to finish them up right now. Okay? So just a friendly reminder, because it's been a little while since you did this. My guess is that you haven't been thinking about this all the time since. Maybe you have. I don't know. It depends on, I guess, what you have going on in your world. Come on. There we go. I want that to go away, but it's not going to go away. A reminder that we're taking big minus little divided by big minus little, right? Change in y over change in x to find the slope, and that's the approximate or average velocity at that point there. And then we did that for 2 books. And I'm going to go ahead and do that for 3 books because I haven't done it yet. So I'm going to say that's equal to, oops, I need a parentheses, big minus little. Never have too many parentheses. When in doubt, add parentheses. And then divided by big minus little. Oh, what just happened? Oh, there. Okay, it's just thinking slowly. I see a hand. Yes, ma'am.
Okay, so you're taking the larger distance minus the smaller distance divided by the larger time minus the smaller time. So like on the C column,
yes,
I'm doing those same steps, but first I got 9.54, and then for the second one I got 11.29. I just don't know what I'm doing wrong.
Let's take a look here. I'm going to go turn the light off too, just so it's a little bit easier to see. I'm going to zoom this in so you can kind of take a look at it here. Let's see if I can get it. There you go. So your values might not match mine, but it's going to be the 18.551 minus the 4.661. Is that what you have?
Why do you skip one of the numbers?
Because so the theory of the intermediate value theorem, right, says that if you've got a curve, I need a marker. If you've got a curve, the slope of this line here is the same as the slope between 2 points on either side of it.
Wouldn't it be more accurate to just try to get the points as close as possible to each other?
Yes. So from a calculus perspective, absolutely would be, right? That's the whole point of calculus, is to make that smaller and smaller and smaller and smaller and smaller. But I don't think that it's fair to just take the distance divided by the time because it's changing. Yeah. So it's more accurate for our purposes to use the secant line. Yeah. Does that answer your question or not quite?
Well, I understand what you mean. Like, we can't just take it at that point.
Uh-huh.
What I was doing is I was taking B51 minus B50 over A51 minus A50. And then I did B52 minus B51 over A52 minus A51.
And you found the average of those two?
No, that was my velocity.
So instead of taking the two on either side, she just did the one after it.
So you use these 2 points to find the velocity for which one?
For C51.
For this one?
Yes.
And then you used these 2 points to find this one? I guess I'm not understanding. Okay, is that what you're saying? Okay. So the issue that I would have with that, and this might be just parsing lack of data, honestly, from trying to meld the calculus with the, discrete points that we have. So what you're doing essentially, instead of doing this, again, if I'm understanding correctly, if this is the point that we've got and here are my other 2 points, is that you're finding this slope and assigning it to this point. And then you're finding this slope and assigning it to this point. Does that make sense? And my understanding of calculus, and it's been a long time since I've done it, but my understanding of calculus is that for the intermediate value theorem, this line here is going to be parallel or pretty darn close. My picture is really kind of icky now, but parallel to that, whereas this one is decidedly not the slope there. Does that make sense?
Yeah.
So we can go through kind of parsing that out another time if you want, because it's an interesting question. But my understanding, and I emailed Mueller a few days ago. I was like, let's talk about this. And this is what we kind of both agreed would be the better choice. But if you want to try it your way and see what we get, that's okay too.
Sure.
I'm down with that. I'm totally down with that. Thanks for asking that question too. I appreciate that. What else? Are we doing okay? Okay. So if you're taking this approach, you have numbers that match these. So now we're going to graph, and we're going to remind ourselves of, what are we doing? We are going to graph. Well, what I really want is to graph this to get acceleration. So what I really want, just kind of a nice reminder here, and you can write this on your notes right now so you don't have to do it later. What I really want to graph here is velocity versus time. Okay? And in theory, if you have something that's accelerating constantly, then the velocity versus time graph should be a straight line, right? Okay, so that's what we're going to graph. Let's go ahead and try it. So on Google Sheets, I'm going to highlight my time. My computer has been so goofy lately, and I don't know why. I'm going to stop recording. That might be what's messing it up. That are not here. So we're just going to tell them this. So we're going to say we see trends. We've got those 3 different graphs, 3 different sets of slopes. It's not perfect. But if you look at those numbers, what kind of a trend do you see between this set and this set and this set? What kind of a trend do you see? They go up? They do go up. Do they go up by kind of an appreciable amount each time? Kind of like squint your eyes and tip it to the side? Like, can you get a sense of what's happening?
Look at 3.
3 is pretty bad.
This is actually pretty good right here.
Like
that's pretty lovely. This is pretty lovely. This is pretty lovely.
The first 2 are weird.
What's happening here? It's going up. You have to remember that it's like it's not perfect, right? And every time we do this, we're messing with the data more and more and more. But do you see that these ones are smaller, and that these are with big waving hands, about half of this, big waving hands, and with big waving hands, this is about half of this. Are you with me there? Okay? Again, this data is terrible, and we could spend all of trimester 2 getting perfect data, and we could show that it actually works perfectly with a board that's not warped and with something better than colored pencils. Are you with me there? But this is pretty decent data for what we did. So the thing that I want you to acknowledge right now, ladies and gentlemen, is that we've got something that's kind of interesting here. We're going to write this down. D is equal to something times t squared. I'm going to put the something in there in just a minute. Put a little box there. Fill in here in just a minute. We're going to write down that V is equal to fill in here times t. And we're going to say that V squared, and that's really a change in V because it's the V final squared minus the V initial squared. V final squared minus V initial squared is really what we're talking about, is equal to fill in here times, D. This is the definition for acceleration, right? Change in velocity over time. Change in velocity over time. I'm going to write it that way. That's actually how we did it before, because when we found a slope, we did a change in velocity, V final minus V initial. V final minus V initial over time is really what? What is that? It is the slope. It's also the definition of acceleration. You with me there so far?
Yeah.
This box, if this is equal to A, this box should be equal to how much of A? I heard somebody whisper it. Half of A. And if this is half of A and this is A, what is this thing going to be? 2 of A. Okay? I'm going to give you something in just a second here. V final minus V initial is equal to A times T. That's a big kinematic equation right there. V final squared minus V initial squared is equal to 2AD. That's a big kinematic equation. D is equal to 1/2. Oops, that wasn't T. You guys didn't call me on that. That's supposed to be a T squared, isn't it? That's supposed to be a T squared. Nobody's like, what are you doing, Carbling? Maybe because you're like, I don't know what you're doing, Carbling, right? It's going to be 1/2 A T squared. There's no initial velocity here. I'm going to throw it in there because the bell's going to ring in just a minute, and we'll talk about why that's true soon. This is the big, big one, okay? Hold on to that. Keep that in front of you right now. I'm going to give you a present. I'm going to give you a present right now. Harrison's going to help me hand him out.
Whoa.
Right? Here it comes. Happy Physics Day to you. Happy Physics Day to you.
This is like you didn't warn me not to be school. The mathematics marinate.
Happy Physics Day to you.
What?
Because they regraph the sheets for a solid concept.
All right. All right. So, Kate is saying prayers or something over there. I want you right now, ladies and gentlemen, to take a look at this. There is a reason that I didn't give this to you earlier. And it's because Kate would have been saying other words that are not school appropriate even. I can't imagine that would be true. But she would be thinking them, and I don't want that. The reason I waited until, 7 weeks into school to give this to you was because you would have been like, whoa! But I want you to just focus on the top left-hand corner of this. That first one right there. Hey, that's right there.
Whoa.
And the second one on there is this one right here. And the third one right here is this one right here. And then, oh my gosh, the fourth one you already know, because it's just acceleration is F net over M. And the fifth one you already know too. Do you see that? And that's all you need to worry about right now. So if you want to just put a little box around that with little happy faces, you can do that. If you want to block the rest of it out for another, couple of days, you can do that. By the end of our year, we will have done all of this. And you'll feel great about it. This is your experience in May. Right now, in October, you're right here. Okay? And that's just fine. All right? Unfortunately, we don't get to play it all today before it's time to go, but I do want you to know that I'd like you to take a look at these problems. And listen for just a moment. If you don't understand them, that's okay. But I know that you know how to write down givens. And I know that you know where on this equation sheet to look. So if you do nothing else, I want you to write down these problems, write down the givens, and try to find an equation. We'll jump in with them tomorrow, okay? Thanks for putting up with some fun today. Have a great day, you guys.